You are looking at the screen of a Sun SparkStation 10 running the Cedar programming environment. This SparkStation is equipped with a mouse for the user's dominant hand and a trackball for the user's other hand. This region of the screen contains a simple window system that we will use to demonstrate a variety of magic lens filters. This lens is an X-ray filter. As we move it over the text using the trackball, the text interior becomes transparent. Filters may change size. A thumb wheel scales this filter to X-ray a smaller portion of the text. Multiple filters may operate simultaneously and with different effects. We can leave the X-ray filter in place and bring in a scaling filter. Filters may also have parameters. For example, the magnification factor may be varied on this scaling filter. By overlapping the filters, we compose their effects. Now we bring in a third filter which tints the region below it. As we position it over the scaling filter, we get scaling and tinting simultaneously. Movable filters can also be used to explore graphical scenes. This filter shows bounding boxes around scene shapes. As we move it over the shapes, we see the bounding boxes in the context of the entire scene. The next filter visualizes the snap-dragging gravity function. For each red point, the filter draws a line to show where our cursor would snap if placed at that point. The points move with the filter, allowing the test to be performed locally. Using a clipboard, we pick up the flamingo and drop it on the hearts. The graphical objects are depth ordered. We can use filters to safely explore the ordering without altering the scene. For example, this filter reverses the depth ordering. It shows the scene back to front, exposing previously obscured elements for editing and viewing. Movable filters can be used across applications. One class of cross-application filter changes basic graphical attributes. For example, on the right we see the Gargoyle graphics editor displaying a drawing of a door. On the left we see the Tioga document editor displaying text and graphics. This magnifying lens operates at the level of the graphics library. Because our text editor and graphics editor use the same graphics library, the filter works over both editors. Another type of cross-application filter has semantics particular to each application. For example, here we see a definition filter. If we select a word in the document, say the word art, the filter displays the dictionary definition of the word. If we select a shape in the graphical editor, then we see a description of that shape. Finding definitions makes sense in both editors. The definitions simply differ in character. We now show Magic Lens's movable filters running in a Unix X environment. Our applications run in several window managers, including OpenLook and TWM, shown here. This window is a map browsing application built on the Suite User Interface Toolkit. The application uses a Census Bureau database of streets and roads. Here we see part of Santa Clara County, California, near San Jose. Suppose my workplace is up here, and I live down here, and I want to prepare driving directions on how to get from work to home. This map is too detailed to show the route clearly, so I bring up a Magic Lens filter which reduces detail. As I move the filter, I hide detail in a local region while maintaining global context. The filter is a standard X window and can be moved and resized like any other X window. Because an X window cannot be updated while it is moved, filter window updating is jerky. By tying window positioning to a second input device, a trackball operated by the other hand, smooth motion and continuous updating of the lens window can be provided by the application. To prepare driving directions, I'd like to reduce map detail almost everywhere. I can do this either by stretching the filter to cover the entire display or by using a global display mode. I'd now like to restore detail in the two areas of interest. I overlay two filters which add detail, one near my house and a second near work. I can use an annotation filter to identify the major road which connects home and work. We see it's Interstate 880. Finally, I'd like the area near my house to be shown close up, so I place a magnification filter over the detail filter. By composing the magnification filter with the detail filter, I get an exploded and detailed view of my home area. I now have an illustration ready for printing. In summary, Magic Lens filters are new tools for enhancing user interaction. Unifying many functions into a single paradigm, they provide a powerful design space for future user interfaces.